Hi everyone. So we continue to discuss the functions on one vector. Okay, so first we want to review the sample variance. The sample variance is a measure of variability. So it represents how much variability the data has. So suppose that we have observations x sub 1 to x sub n. So these are, for example, the weights of n different babies. Then sample variance S sub x square is defined as 1 over n minus 1 times summation of xi minus x bar square. So xi minus x bar is distance between xi and the center of the data x bar. So if we take summation and take average, then it is a kind of typical distance from center to each observation. So that's why we define S sub x square as this. So at first, why we got 1 over n minus 1, not 1 over n? So the reason is that S sub x square is usually too small when n is small. So imagine an extreme case that we only have one observation, x1. Then x bar is the same as x1. So actually x1 minus x bar is 0. But this is just because x bar is too much affected by xi. So if we observe more observations, then we should have larger variability. So to adjust that factor, we put negative 1 in the denominator so that when n is equal to 1, we cannot define the sample variance. It's consistent with the fact that with one observation, we cannot really evaluate the variability of the data. Second, why we take square of xi minus x bar? The one reason is that we want to focus on distance. If we don't put square, then summation of xi minus x bar cancel. So actually this s sub x square would be 0. So that is useless. So that's why we put square here. We have several different reasons. S sub x square is a kind of distance measure between the center and each observation. What's the distance in Euclidean space? So distance between Euclidean space, in Euclidean space, for example, the origin and the point AB. What's the distance? That is actually square root of a square plus b square. So it's natural to take summation of the square of something. So the variance, the definition of variance is consistent with that Euclidean distance. This is also related to the normal distribution and maximum likelihood estimation. And the other reason that we take square is the future extension. So later, we define the concept of covariance. The covariance is defined for two variables, x and y. For example, how closely related x and y are. So to define that, we replace the one of parentheses by yi minus y bar. So to get the smooth extension of variance, that we take square here. If this is cube or fourth power, it doesn't work in that easy way. So that's the reason that why we define s sub x square as this. Okay, so now that we define sample variance, but what's the unit for sample variance? Suppose xi's are all in kilogram. What's the unit of s sub x square? You can see that we take square of these numbers, so that means the unit is square of kilogram, which does not make sense in real world. So probably s sub x square is harder to interpret in real world, so we take square root of this, then we define s sub x as sample standard deviation. So this has the same unit as original observations x1 to xn. So this is more interpretable measure of dispersion or variability. Okay, so now we want to calculate the sample standard deviation in R. So remember that last time we defined weight of 5 babies. So these are numbers. So now we want to calculate the variance and the standard deviation. So variance of weight is just the VAR, all lowercase weight, 0.492. Oh, by the way, the function and the objects are case sensitive in R. So if you type the capital V, then it returns an error. Okay, so if you want to calculate everything from scratch, okay, so we have 5 observations. So 1 over n minus 1 is 1 over 4. Then we take the summation of the weight minus sample mean of weight. Then we take square. So weight minus mean of weight. We want to put this, then square, then take summation. Then we want to divide this by, oh, we have already divided by 1/4. So this is the number. So we get the same number, 0.492. Also, we have the standard deviation function, SD. SD of weight is square root of 0.492. So these are how to calculate variance and standard deviation.